Hi guys! So today we are going to be continuing with our 6-1 notes. So yesterday we worked with our negative exponents, our zero exponents, and if we were multiplying with the same base. All of those are going to come back today, but we are also going to add in some new concepts. The first of which is raising a power to a power. So to find a power of a power, you multiply the exponents. So remember yesterday, if we were multiplying with the same base, we added the exponents. In this case, if we just have a number raised to a power and then we are raising that whole thing to a power, you will multiply your exponents. So I did give a little example here. For instance, if we had 4 squared raised to the third power, you would do 2 times 3. You would just multiply those exponents, and you end up with 4 to the 6th power. So going into some examples, all of our first examples here just have letters. We don't have any numbers that we're incorporating just yet. For this first one, we have n to the 4th raised to the 7th power. So n to the 4th to the 7th power. So we are going to do 4 times 7, which is going to give us n to the 28th power. Number 2 is very similar. We have p to the 5th power raised to the 4th power. So we do 5 times 4. And 5 times 4 gives us 20. And then the last one is just slightly different. We have p to the 1/2 raised to the 1/4. We still follow the same process. We still are multiplying those exponents. However, fractions always just seem a little scary, so just remember when multiplying fractions, you multiply straight across the top, straight across the bottom. So 1 times 1 is 1, and 2 times 4 is 8. So we get p to the 1/8. And that is all it is asking us to do on these. There's no other solving necessary. We were just simplifying those numbers that they gave us, or letters in this case. In the next section, we go into simplifying expressions. So expressions just means we're going to have more than one step we have to do in order to simplify. For number 4, we have x squared times x to the 6th raised to the -4th. So just like yesterday when we were looking at those negative exponents, I was always putting a box around them to show what it was attached to. So this -4 is only attached to that x to the 6th power. So this x squared just kind of stays out front for now. And then we have x to the 6th times -4. So that's going to be our first step. We have to simplify that power raised to a power first. So we still have this x squared out front, and now x to the 6th times -4 gives us x to the -24. So now this brings in stuff from yesterday. We are multiplying 2 things that have the same base. So remember, that means that we keep our base, and now we are going to add those exponents together. Because now we're multiplying, we're not raising a power to a power. So we have to add those exponents. 2 plus -24 is -22. So again, bringing in more stuff from yesterday, we have a negative exponent. Remember, negative exponents, to make them positive, we just have to move them in our fraction. So in this case, we move it downstairs, and we get 1 over x to the 22nd power. In this next one, we have y to the 3rd power times y to the 5/2 raised to the -2 power. So again, that -2 power only applies to this y to the 5/2. So this y to the third, we just kind of keep out front for now. And then we have y to the 5/2 times -2. This -2 is kind of over this imaginary 1, so that helps you again when multiplying these fractions. So we still have this y to the third out front, and then this y to the 5/2 times -2. We do 5 times -2, which gives us -10. And then 2 times 1 is 2. Now, this little fraction here, that is our exponent. That can be simplified, and I highly suggest you simplify the fraction, because then it turns into y to the -5th. Because -10 divided by 2 is -5. And so now we are multiplying two variables with the same base. So again, looking at the stuff we did yesterday, we are going to add those exponents. So we have y to the 3 plus -5. 3 plus -5 is -2. So we get y to the -2. In order to make that positive, we have to move it down. So we get 1 over y squared. Sorry, there was not a lot of space there for you to write that all out, but hopefully you were able to follow through with where everything was coming from. And last one like this, so we have s to the -5th raised to the -1/2. So again, I'm going to go ahead and put a box around that, just so I know that that -1/2 goes with that s to the -5th. And then we have it times s to the 3/2. So first thing we have to do is this -5 times -1 over 2. And this s to the 3/2 just kind of stays over here. Again, remember this -5 is over this imaginary 1. So when we multiply across, -5 times -1 is +5. And then 1 times 2 is just 2. And we bring down this s to the 3/2. So now we have same bases. So we do s to the 5/2 plus 3/2. Since they have the same base, we add those exponents. When we add fractions, we only add across the top. Remember, they have to have the same denominator to be added, but we do not actually add those bases together. So we only add the top. So 5 plus 3 is 8. On the bottom, we just keep 2. And then again, you want to simplify that fraction if you can, to which we can. 8 divided by 2 is 4. So we end up with s to the 4th power. So these simplifying expressions brought in a lot of stuff from yesterday, and then also still brought in the new concept of raising a power to a power. So next, we talk about raising a product to a power. So to find a power of a product, you find the power of each factor and multiply. So kind of a general setup, if you have a times b raised to the m power, you have to distribute that exponent to each piece inside the parentheses. So you have a to the m power times b to the m power. So that exponent has to be distributed to everything on the inside. Kind of think of it like our regular distribution concept, except now it's an exponent instead of a number out front. So for number 7, we have 5x squared to the second power. So that second power has to go to the 5, and it has to go to the x squared. So you would have 5 squared And then x squared to the second power, you will multiply those exponents because it is a power to a power, which would give us x to the fourth. And then just to simplify it further, that 5 squared, remember that is 5 times 5, which is 25. So we get 25 x to the fourth. Number 8, we have 2z to the negative fourth. So again, that negative 4 has to go to the 2 and to the z. So we would have 2 to the negative fourth and z to the negative fourth. Now we have negative exponents, and our final answer cannot have that, so we have to get rid of those negative exponents before we do anything else. Remember, this is over that imaginary 1. Since everything up here is negative, everything has to get moved down. So we end up with 1 over 2 to the fourth, z to the fourth. When we move it down, it makes it positive. And then our last step is just to simplify that 2 to the fourth. So remember, that is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we get 16 z to the fourth. And our last one, 7m to the ninth raised to the third power. That 3 has to go to both pieces on the inside. So we have 7 to the third power. And then that m, remember, we have to multiply our exponents since it is a power raised to a power. So we have 7 cubed m to the 27th. And then final step, make sure we simplify that 7 cubed, which is 343 m to the 27th. We don't have any negative exponents, so we don't have to worry about bringing anything down. So now we're going to apply that information into an expression. So we're going to have more steps that we have to do, kind of incorporating all of the stuff we've learned so far. So we have x to the negative 2 raised to the second power. So we have this piece. And then we have 3xy to the fifth raised to the fourth. And so remember that 4 has to get distributed to every piece on the inside. So initially, this x to the negative 2 times 2, x to the negative 2 raised to the second, we have to multiply those exponents. So negative 2 times 2 is negative 4. And then we have 3 to the fourth, x to the fourth, and then for that y, we already had it to the fifth power, and we are raising it to the fourth power. So we multiply 5 times 4, and we get 20. So notice that we have this negative exponent with our x. Now, before we think about moving that down, we first want to see if we have anything to simplify that with. In this case, notice that we are multiplying by this 3 to the fourth, x to the fourth, y to the 20th. So we also have this y to the fourth. So they have the same base. Remember, if they have the same base, we add the exponents together. X to the negative fourth, x to the fourth. If we add those together, negative 4 plus 4 gives us 0. And remember, anything to the 0 power is just 1. But so the idea of x goes away because it's just the number 1 now. There's no more x there. So we are just left with 3 to the fourth, y to the 20th. And then the last step we have to do is just simplify that 3 to the fourth, which is 81. And then we just have this y to the 20th to tack on at the end there. All right, number 11 says 6ab to the third power and 5a to the negative 3 to the second power. So in both cases, we have to distribute that exponent to every piece on the inside. So for that first piece, we have 6 to the third, a to the third, b to the third. And in the second piece, we have 5 squared, a to the negative 6, because we do negative 3 times 2 to get negative 6. So we're going to start kind of simplifying this a little bit. So let's do 6 to the third. So 6 times 6 is 36. 36 times 6 is 216. And then we still have this a to the third, b to the third. And then we have 5 squared, which is 25. And then we still have this a to the negative 6. Remember, we have these numbers here. We have 216 and 25. They are being multiplied. That still has to happen. That should be our first thing that we look at. So 216 times 25 gives us 5,400. And then we have a to the third and then a to the negative 6. So we have the same base, so we need to add those exponents. 3 plus negative 6 is negative 3. And then we still have this b to the third. We have this negative exponent here, so we have to move that into the bottom of our fraction. So we are left with 5,400 b to the third up top, and then a to the third on the bottom. So these start to get really intricate, just all the different little pieces that you have to do, remembering the previous lessons, different things that we know. So just kind of keeping them all straight, that is going to be the most tricky part. The next thing we learn is dividing powers with the same base. So if we are dividing powers with the same base, you are just subtracting those exponents. So multiplying with the same base, you add. Dividing with the same base, you subtract. And again, this can get a little tricky when you get those negative exponents. In number 12, we have m squared n to the fourth over m to the fifth n cubed. So my tip for this, whenever we are subtracting, is wherever your larger exponent is where your final answer will go. So, for instance, m squared over m to the fifth. Those have the same bases, m and m. So you look at your numbers. You have 2 and 5. We have to subtract since we are dividing. So 5 minus 2 is 3. Now, m to the fifth was our bigger exponent, right? 5 is bigger than 2. So that m to the third power is going to stay in the bottom of your fraction. So our new answer is going to have m to the third on the bottom for sure. And then our other variable we had was n to the fourth and n to the third. So again, same base, so we have to subtract our exponents. Our exponents are 4 and 3. 4 minus 3 is just 1. And 4 was our bigger exponent, which was up top. So that means our final n variable would be up top. And in this case, we were just left with n, since 4 minus 3 was 1. Number 13 has k to the sixth, j to the second over k, j to the fifth. Okay, so first we're going to look at k's. So we have k to the sixth over k. K to the sixth is our larger exponent. So our k variable is going to be on top of our fraction. K to the sixth, and then k by itself. Remember, k is just to the first power, so you have to subtract those exponents. 6 minus 1 is 5, so we have k to the fifth. And then we have j squared over j to the fifth. So j to the fifth was our larger exponent, which means j is going to go on the bottom because that's where j to the fifth was. And then we subtract our exponents. 5 minus 2 is 3, so we are left with j to the third power. And our last one, we have x to the fourth, y to the negative 1, z to the eighth, over x to the fourth, y to the negative fifth, z. So notice we have these negative exponents. Personally, the first thing I want to do is make those positive. So to make this guy positive, it has to move down. And to make this guy positive, it has to move up. So our y's end up trading places. That's not always going to happen, but in this case it does. So now I'm going to rewrite my equation. So I still have that x to the fourth and z to the eighth up top, but now I have y to the fifth. And then on the bottom, I have x to the fourth, y to the first, and z. Okay, so now I can start simplifying. So I have x to the fourth up top and x to the fourth on bottom. Since those are the exact same, they're just going to cancel each other out because 4 minus 4 is 0. Anything to the 0 power is just 1. Then we have y to the fifth and y to the first. Y to the fifth is our larger exponent, so that means y is going to be on top of our fraction. 5 minus 1 is 4. And then we have z to the eighth over z. So again, z to the eighth is our larger exponent, and it's up top. That z has this imaginary 1 exponent. 8 minus 1 is 7. And you can put this over that imaginary 1. You don't have to. You could just leave it as y to the fourth, z to the seventh, and that works fine. And the last thing that we have to learn about today is raising a quotient to a power. Very similar to what we did with raising a power to a power, except with a quotient. Quotient means division. You have to distribute that exponent to the top and to the bottom. So you distribute it to every piece up top and every piece on the bottom. So the first 3 examples are those simple kind of one-step problems. So we have this 3/5 to the third power. So that 3 exponent gets distributed up top and down below. So that gives us 3 to the third power over 5 to the third power. 3 to the third power is 27. And 5 to the third power is 125. So as simple as that, you just have to distribute that exponent to every piece up top and every piece down below. For 16, we don't have numbers. We are just dealing with variables, but still the same concept. We have x over y to the fifth power. So we distribute that 5 up top and below. So that gives us x to the fifth over y to the fifth. And that's as much as we can simplify that one. And last of the one steps, we have 4 over x cubed raised to the second power. We distribute that second power to the top to get 4 squared. And then on the bottom, we have x to the third raised to the second power. So remember, that means we multiply our exponents. So that gives us x to the sixth. And last thing we need to do is simplify. So that 4 squared simplifies down to 16. And then on the bottom, we still just have that x to the sixth power. And for our last 3 examples, we're going to tie everything in together to see how everything kind of works to give us our final answer of simplifying these expressions. For number 18, we have 2x to the sixth over y to the fourth, and all of that is raised to the negative third power. So remember that negative third power goes to everything inside that parentheses, so everything up top, everything down below. So we get 2 to the negative third, x to the sixth raised to the negative third. We have to multiply. 6 times negative 3 is negative 18. And then same idea on the bottom. We have y to the fourth raised to the negative 3, which is going to be y to the negative 12th, because again, we multiply. Very, very important right here, that 2 to the negative third power. You cannot do until you make that exponent positive. Do not try and do 2 to the third power and change that to 8. We cannot do that yet because it is a negative exponent. All of these have negative exponents, so we need to completely rearrange this problem before we do any simplifying. So this guy of 2 to the negative thirds and x to the negative 18ths, they are both negative, so they have to get moved to the bottom. And our y to the negative 12th has to get moved to the top. So now we have y to the 12th up top, and then on bottom, we have 2 cubed x to the 18th. Now that everything has positive exponents, we can simplify, so that 2 to the third we can now say is 8. And then nothing else really simplifies, so we just tack everything else along with there. Number 19, we have a over 5b, all raised to the negative second power. Again, remember that negative second power goes to every single piece inside that parentheses. So we end up with a to the negative 2 over 5 to the negative 2, b to the negative 2. So very similar to our last one. Going to have to completely rearrange this problem because every piece has a negative exponent. So this guy has to move down, and these two have to move up. So we end up with 5 squared b squared over a squared. And then we just have to simplify that 5 squared to be 25 and tack everything else on. And then comes our last and final problem, probably the most intense one we've had so far. X, y to the fourth, z to the negative second over x, y to the third, z to the negative second over, all raised to the negative second power. Very first thing you have to do is deal with that outside exponent, that negative 2. So we have to distribute that to every single piece inside. So every piece up top, we have x, you know what, I'm going to do this in a different color actually, so it doesn't blend in with everything over here. So we have x to the negative second y to the negative 8, because we do 4 times negative 2, and z to the positive 4, because we have negative 2 times negative 2. And then on the bottom, x to the negative 2, y to the negative 6, because we have 3 times negative 2, which gives us negative 6. And then z to the 12th, because negative 6 times negative 2 gives us a positive 12. Okay, so at this point we have to do some rearranging. Now you will notice right here we have x to the negative 2 over x to the negative 2. Those guys are just going to end up canceling out. There's just going to be 1 left there, so we don't really have to worry about moving those around. But then we have this y to the negative 8 and y to the negative 6. So that y to the negative 8 has to move down, and that y to the negative 6 has to move up. The z's stay in place because they are positive. And now notice we have y up top and y below. On bottom, we have y to the 8th, which is our bigger exponent when it comes to the y's. So that means y is going to stay on the bottom of our fraction. We subtract our exponents. 8 minus 6 is 2. So we now just have y to the 2nd power. And then we notice we have z to the 4th up top, z to the 12th below. Z to the 12th is the larger exponent. So z is going to stay on the bottom of our fraction. And then 12 minus 4 is 8. So we have z to the 8th power. So the only thing that's left up top in our fraction is 1. So our final answer is 1 over y squared z to the 8th. Feel free to go back through this video at any point. I know I kind of sped through some of that stuff, but go through, find the section that wasn't making sense, re-listen to it, and then, of course, ask any questions if you're confused on anything. But that finishes up the notes for today.